All right, I just started the recording, so good morning, everyone. We are going to continue where we left off last time with this first module. So quick summary of where we were at, and then we are going to dig right in. So we talked about what programs are, what compiling a program and running a program means. That was the first on-topic lecture. Then last time we looked at one example of a very simple, a trivial Java program, hello world, and we kind of dissected it and we took a look at all the components of it, all the parts, try to explain to you what's going on here, talk about the syntax, stuff like that. And then we finish the session by running it and compiling it. Well, other way around, compiling it first and then running it, of course. But this time we did it from the command line interface. Okay, so we are not going to use the command line interface on a daily basis in this course, right? We're going to use JGraphs because it's much more beginner friendly. But what I wanted to show you is I wanted to demystify what JGraphs is doing. It's just a text editor, really, that is, in addition to editing text and providing syntax coloring and all those neat little features, also call upon the tool that you install with the JDK, which are the javac and Java commands that actually do the job. One of them compile your code from a .java file to a .class. Another one runs actually whatever code you have in your .class. So where are we going from here? So we are going to wrap up this first module. I just have a handful of slides to go through, and then we'll be done with module 0. And then we'll start immediately module 1 during the session, okay? So the topics that I have left to cover for module 0 are a little bit of advice on how to write clean code, and I'm going to give you guidelines that we are going to follow all together this entire semester. And then we're going to start talking about bugs because, yeah, we are going to encounter bugs right and left. That's a normal part of programming to actually have bugs in your program. And it's a normal part of programming to know what to do when your program doesn't work as expected. So we're going to start laying the foundation layer on what kind of bugs can you guys expect and how to deal with them. All right, so let's start with some elements of programming styles and documentation. So I'm not going super formal on this for this introductory course. However, I'm going to set some clear expectation on how your code should look, okay? And even if you don't believe me entirely that this is a good idea to write code like this, please do so, at least for this semester, okay? So that I try to give you some good habits for you to build on in the next classes and stuff like that. So let's take a look in detail about what I'm talking about. All right, so I found that on the internet. You find everything on the internet. It's great, right? True programmers do not comment their code. It was hard to write, then it should be hard to read. I really hope that none of you actually agree with that, okay? Because this is really counterproductive in the real world, in real project when you work with other programmers, okay? So what we're going to do in this class, I'm going to try to get you in the habit of commenting your code, and I'm going to actually require some mandatory comments to be actually in the code from time to time, okay? Some specific comments to be in the code always, I should have said, sorry. So let's take a look at the syntax for adding comments to your code. So we've seen already some of it, right? Like if I go into live coding here a little bit, and I use this / forward / right? I told you that everything before that on the line, for example, system.out.println, you see how it's colored by JGraphs, okay? This is actually Java code. And then everything that I type after the / on my line, for example, system.out.println, well, that's not going to be recognized as Java code. This is in red, this is command. So everything from the moment you type / to the end of the line is command. And if I go to the next line, again, typing the same thing for consistency, right? Well, this is the next line. This is another statement. No problem there. This is actually not considered command. Okay. So these are good for one-line commands. Like for example, we are going to get started declaring variables, etc. in the next module. Every time we declare a variable, it's nice to have a command that say what that variable is doing. Okay, so this is what this is about, like a quick inline command. And then sometimes you want multiple line commands, like you would like to say, for example, this exercise is just to be practiced, okay? To practice compiling and running code. And of course, if I want the second line to be also a command, I have to prefix it by // that's nice, okay? But you have to do that for every line that you are going to type, okay? Of course, some IDEs, I don't think Grass does that, but some IDEs allow you to select multiple lines and use a keyboard shortcut, to just turn them into command or uncomment them. What we're going to learn to do here for this class is we're going to use another syntax of the Java language, which is the multi-line command. So // one line command, /*, you open, just like when you open a curly brace, right? You open a multi-line command. And you see that the graph is saying, okay, fine. So this starts a command. And now it's looking for a character, a special character that's going to mean this is where the command ends. I want the command to end here. Unfortunately, I didn't specify where the command ends. So JGrass thinks that all of this is actually one giant command. If I try to compile this, there we go. It's going to tell me even this message is pretty clear, right? On line 4, I have an unclosed command. And the hat here points to the beginning of line 4, which is this here makes the Java compiler think that there is an unclosed command. Well, yeah, I never closed it. So guess what? How do we close a command that has multiple lines like that? */. That's it. /* to open, */ to close. You're going to see also sometimes people write this, like double star. So this one has a special meaning. We're not going to use it until COP2513, but this one has a special meaning. But the rule of thumb is, you can type whatever you want here, okay? This is your command area, so you can type whatever you want. Java just looks for the start of the command, and then it keeps looking at something that is going to close the command, and then that's the end of the story. Okay, so we can have, for example, before, at the beginning of our file, we can have something that's going to say, okay, this is the author of this program, this is the goal of this program. There is an example in the slides, okay? So it's a good idea. It's not only a good idea, but I'm going to require you to put that every time you have a Java file, there should be a few lines of comment at the beginning of the Java file that allow me quickly to just read those few lines of comment and know what this is about, okay? So we do exercise, so they should have the number of the exercise, a reference to the module, maybe stuff like that, your name and things like that. You're going to put that there. When we write multiple method, for example, if I was to add a method public void do something, blah, 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 well, I would like to remember what that method is doing. So again, multi-line command. Okay, and I could say something like this method does something very interesting. Okay, stupid comment, but just to illustrate the syntax. Okay, all right. So this is it for single line commands, and that's one, and multi-line command. This is it as far as the syntax goes. The only trick about those, the only thing that can get tricky with those, is if you are trying to put comments inside of comments. Okay, so right now my code compiles. Let's say that I want to comment out an entire method. How could I do this? Like this, right? Open a comment before the code of the method, close the comment after the code of the method, and now it's kind of like my method is not going to compile anymore. Okay, it's not there. So the rest of the code compiles, but for example, here I compile my code, and if I was trying to run it, it tells me you don't have a main method. Well, yeah, I commented it out. So commenting out code and then putting it back in is something that we do often, especially when we're trying to look for the source of a syntax error or something like that. We want to temporarily remove a part of the code. Well, instead of deleting it, we can comment it out like this. But as you do so, you are going to stumble across a situation where, for example, you had a comment here, okay, right in your code, and you commented out your main method. So you commented out a bunch of lines. including a line that contains a comment. Java doesn't have any problem with that, as long as we are talking about one-line comments. Okay, let's see what will happen if I try to do this again. But here, instead of using a one-line comment, I would have, for whatever reason, use the multi-line command, even though really I had only one line of command there. Okay, so I use the syntax /*// to encase a comment. Okay, for whatever reason. And now I'm thinking, okay, I want to temporarily remove from the code my main method. So I open the command here, and look what happened already. This is red. This is comment. This is comment. But it stops there. Why? Well, there's a closing comment, right? So it totally ignored that I was opening another comment nested inside the other comment here, okay? It totally ignored that, but it was looking actively for a // to know where the command ends. And the first time it finds one, there you go, that's it. That's my end of comment. So there is no way for me to pretty much make Java understand that I would like this close comment syntax to match this close comment syntax. Okay, so it's up to you. Use only one line command like that most of the time so that you can easily comment out code, or just fix it when it happens. Whichever way is fine. Okay, I'm not going to push one way or the other. The bottom line is you have to be aware that you cannot nest multi-line commands inside multi-line commands. That's not going to compile. Okay. All right. So let's save that. Actually, I need a main method to do anything, so I'm going to uncomment this, save it, Control S, Control B to build it, compile it, and then Control R, sorry, to run it and make sure it's still working. Okay, we're back on tracks. So this is what I wanted to tell you here in this slide about the different things that you need to be careful about regarding the Java comment syntax. Now, the other thing that I want to comment on, no pun intended, or was there, is there is such a thing as over-commenting. So here's what I'm going to require you to do, okay? I'm going to require you to have like a multi-line comment at the beginning of your file that explains pretty much, the offer, goal, etc. I'll give you a format for that, okay? And then whenever we declare a variable, which I'm going to show you in the next module, I'm going to ask you to comment the role of that variable. Every time you create a new method, I'm going to have you put a multi-line comment before that method to tell me what this method is about. Okay, so the idea is if you create a new class, tell me what it is about. If you create a new method, tell me what it is about. So the main method is always pretty much standard, right? So the multi-line comment here is optional, okay, but you could say this is our main method, right? You could say that, but this is getting a little too much commenting, okay? What do I mean by too much commenting? Well, let's take an example of a student who says, or a programmer who says, okay, this is my main method, public static void main. I can see that, yeah, I know how to read Java. Public static void main means it's your main method. But then here you would put a comment that say, this displays hello on the console. This displays nothing but goes to the next line. Okay, this is too much. Okay, this is where I draw the line for commenting, because what you are doing is you are translating the Java code into English. That's not what comments are good for, okay? Your comments do not need to translate all of your Java code, every single statement, into English. When you comment code, you comment for somebody who is literate in that programming language. So you comment for yourself later, like 6 months later, or you comment for your colleagues that are working with you on the project, okay? So you don't translate the code. What you explain is why you write this code, okay? So here the why, there's no really why, this is a main method, but this part here, yes, it's important. It tells me who I have to fire, if that code doesn't work. It tells me what the code is supposed to do at a high level without details, and then the code will provide me the detail, okay? This tells me what this method is going to do, and if I wanted to put a statement here, a comment here, I would just put something that say displaying our message on the screen. Okay, and the formatting of it, what the message consists of, like if I want to skip a line and then display system.out.println, word on another line like this, all of that, it's the code. Okay, the code is going to show me exactly what's happening. Display this, then skip a line, then display that. Okay, that's it. So you don't have to retranslate that, but you can give me an idea of what is your goal here in that part of the code. What are the next few lines going to do? And then there's going to be stuff that could be considered redundant. I'll be honest with you, it is redundant, but I still want you to do it, okay? It's just because it helps students avoid what I called last time curly brace hell. So what is curly brace hell is when you have a lot of code, you open 50 curly braces, you close 49 curly braces. And then you compile and the compiler tells you, this is not working. There's something wrong here. Illegal start of expression. What does that mean? You started typing something and I didn't expect that. So I expected something else before it. Well, yeah, I just forgot to close the curly brace here. So to avoid having to deal with this, I told you already that when you open a curly brace, you should type immediately the closing curly brace, then go back in the middle and add your code right there, okay? Well, I'm going to ask you to do one more thing. When you close the curly brace, tell me what it closes. End main method. And do something method. And this is going to allow you very quickly, like in the next week and a half or week maybe, we are going to start like nesting things inside one another. We're going to have a bunch of curly braces everywhere. This is going to help you keep track of how you open and close your curly brace, match them so that you can easily read your code and figure out, for example, that this here is the curly brace that closes my class. So that should be the last closing curly brace in my file. If I'm missing curly braces, I need to add them before. This is the curly brace that closes my method do something. If the method do something is okay, compile okay, then I don't need to mess with that. This is a curly brace that closes the main, and so on, so forth. Okay. Naming convention, I think I pretty much already covered that. Let me move this guy out of the way here. So naming convention, the camel case. I told you class names always start with an uppercase letter. Method names always start with a lowercase letter. Well, very soon we are going to start introducing variables, okay, next module, like actually probably in the second half of the session. So when we have variables, same thing, the name of a variable, which is a way to store a value in memory, is going to be starting with a lowercase. And if it's a name that is made of several words put together, then you are going to use uppercase for every the beginning of every word that constitute that name. Okay, so we covered that. I'm not going to go spend too much time on it, but every time I try to speed up like that, if it's not clear to you, please feel free to jump in, okay? I try to find the pace that is going to be comfortable for most students. So I try to gauge, what is easy and I can brush on, because I already mentioned it several times, and what is hard and I need to pause, slow down, and explain, in detail. But the best way for me to know when I need to pick up the pace and when I need to slow down is your feedback. So again, like we discussed last time, the chat window is right there. I'm keeping my eyes on it. Let me know if I'm going too fast, okay? All right. So naming convention, we talked about them. Another topic that has to do with code style, etc., is the indentation and the spacing of your code. So I'm just going to give you some advice to make your code a little bit easier to deal with, a little bit more readable. So we haven't done mathematical expression yet, but if I want to display the result of 2 plus 3, okay, I can do it like that. So Java is going to understand all the basic arithmetic expression that you have learned in the K-12 environment. Okay, so there we go. 2 plus 3 equals 5, and then it displays the result. So it evaluates that expression. 2 plus 3 equals 5, and then the 5 is given to println so that println does its job and displays it on the screen. Well, all I'm saying is this might be a little bit more readable than, for example, if I cram everything like this. Okay, 2 plus 3 times the multiplication is a star symbol times 4 divided by the divided operator is a slash divided by 3. Well, that formula is maybe a little bit harder to read than if I space the operand and the operators like so. Okay, so this is just this is like minor stuff. Okay, minor advice. What another thing I would ask you to do, and you have seen me do it consistently since the beginning, but I indent my code. So nothing new for those of you who studied Python already. In Python, you don't have a choice. You have to indent your code or it doesn't compile. Well, in Java, we have this curly brace system, okay, to tell us what is a block of code. And we have the semicolon to separate two statements, which means that, here we go, let's go and write things as dirty as we can. I'm going to remove that comment for now. I'm pretty much rewriting my code here like a pig, okay? I'm not indenting. I am putting like a bunch of things on the same line instead of separating them cleanly on several lines. Like there we go, this method is empty. There we go, I'm going to write it like that, okay? And then if I try to save this, let's see how picky the compiler gets, right? The compiler, in this case, I didn't do anything to offend the compiler, okay? The compiler is perfectly okay with this, and if I run it, it's still doing the exact same job, okay? So what does that mean? That means that when you type code, the compiler is going to do something called parsing, which is pretty much, okay, I recognize a public keyword, I recognize a class keyword, this is a name, that has to be the name of the class. This class definition starts here, it ends there. And it's going to use all of those rules to kind of dissect what you typed and figure out what you want it to do. But spaces, tabulation, like when you hit the tab key, you know, you indent to the right. Space, tabulation, new lines, I can almost put them anywhere. Okay, you saw last time in the lecture that I cannot, for example, put a new line in the middle of a string literal. But other than that, look at the mess that I'm doing here. Okay, my code is really bad. So why is it bad? It's not bad in the sense it compiles, it runs, and it executes exactly the same way that the previous version. It's just unreadable. Nobody wants to work with this kind of code. So sometimes I see students, you know, that type code like that. They don't go as far as this. Okay, they don't make it that ugly. I did it really ugly on purpose, but they are going to do stuff like this. All right, there we go. Let me remove this. Generally, people that do not indent also do not comment, okay? Because why bother with one if you don't bother with the other, right? And there we go. So this is code that would cost you points in an exam, okay? Simply because as a programmer, I look at this, and this is like, you know, those end user license agreement that you have to click to agree on about everything that you download or install, etc. You see how they are spelled in all uppercase letters, right? And it's like a block of text that's like all uppercase letter. It's hard to read, right? Well, so is this. Okay, this is this is a programmer that is purposefully making their code harder to read. And it's harder to read because I don't even know what's going on here. There's a class here. Where does my class start? Well, here. Where does it end? I'm not sure. Maybe there are two classes, one after the other. There is no help for me to know how many classes are there. If I indent things like that, yeah, now it makes sense. Okay, the class starts here, and here the closing curly brace is indented with a statement that where it opened, and all of this is inside the class. So what do I have inside my class? I have a big block of, okay, something, all right? That's not readable. So here's my main method. It starts here, it ends here, and I'm going to indent again and push all of this code with a tab key to the right. And there we go. And then there is another method. So I'm going to put a blank line here to separate. This other method is empty, so you could leave it like that, okay? But I'm going to be just a little pedantic. This is my method. And then end of public class, end of do something method. Now I'm starting to have code that is easier to work with, okay? So do it because I tell you, if you are like a person that needs, you know, authoritative, do it because I ask you to do it, and do it because maybe I'm going to remove points from your exam if you don't do it. But I hope that you are going to realize that there is a value to that. Maybe just by not doing it and then realizing that you spend twice as much time trying to figure out the kinks of your code compared to your classmates. But I would really like to hear from you. If you really think that this is not useful, I definitely want to hear from you because I want another chance to convince you otherwise, okay? If you are convinced, if you actually see the benefits, then it's going to stop feeling like, oh my God, I have all those rules to abide by that I don't care about. It's going to feel like, okay, now I understand the value of this rule that he's forcing me to comply with. Okay, I'm going to get good at it. Okay, it's a much more positive learning environment than if I just force you the hard way, to do things right. All right, and then just to make it easy on everybody, what if I have like some really crappy indentation here? There we go. Okay, let's say that I didn't indent, I didn't care about indenting at all. Okay, there we go. Even if you don't indent as you type, which I strongly recommend, okay? Remember, open a curly brace, close it, indent it, comment, now you are jiving, okay? So even if you don't heed my advice and you somehow type your code, blah, 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 and then you are going to turn it in, before you turn it in, once your code compile, and it has to compile to be able to do what I'm going to show, okay? If your code compile, if your code is correct, so the curly brace match, etc., and you just wanted to make it more presentable, here's a button that's going to help you. The one that's just under the S of settings, okay? You click that, it adds structure to your code, and it indents it. And then if you don't like seeing that blue stuff, I personally don't care much about it, then you click the next button. This one was called Generate CSD. This one is called Remove CSD. The CSD are those blue things, okay? I remove it, but if I generate and remove it, at least JGrasp indented my code correctly. So you have zero excuses to not have a code that is properly indented, clean, easy to read, okay? The IDE will even help you get to that point. So that's why when you submit something in the following IEs, etc., you need to absolutely make sure that you indent properly and stuff like that, okay? All right, last thing that's going to be a little subjective, and then we're going to move on to different pastures. So according to the internet, one of those three things is purely evil. Number one, I'm opening curly braces at the end of a line. Okay, so this is the beginning of my class. This is where the class starts, at the end of the line where I declare public class hello world. And then I close it aligned with the P of public, okay, indented along with the P of public. The other thing that you could do is, because Java is permissive, you could say, when I declare a class or a method, I'm going to write public class hello world, and then at the beginning of the next line, open my curly brace so that when I close it, it clearly aligns to the opening curly brace. Some people like this. Some people like this. There is actually a semi-objective reason for which this version is maybe a little less safe than this version. But bottom line, two versions of the code are going to compile, are going to run. So it comes down to preference, okay? If you work for a company, they're going to tell you exactly how they want you to handle their curly brace, again, for the sake of consistency across all programmers. In this class, I don't care, okay? You can use this style, or you can use this style. You let JGrasp, indent the code for you, go with whatever default it's doing. I'm fine with every style. Just use consistently the same style in your file. Don't start opening curly braces at the end of lines, and then midway through your code, start opening curly braces at the beginning of lines for no reason, okay? Be consistent. Other than that, this is one of those flame wars, right? So it's one of those things where people get really emotional about it sometimes. Like I said, there is maybe a little bit of objective reason for which this one is a little better, but there's a lot of noise on the internet about, this is bad, but you're used to that, okay? You know what this is like. So this one is not super critical. All right. That's it for the rules of code presentation, aesthetic, how it's going to look like. Now let's talk a little bit about how we are going to deal with bugs. Okay, this is going to be a lot less subjective. Okay, so what are bugs? We are going to talk about three kinds of bugs in this class and the next. Okay, these are the only three kinds of bugs you are going to to encounter, consider these as families of bugs, categories of bugs. The first one, syntax errors. So remember, when you write some Java code, right, you write a Java file, a .java file, this is a text file. You compile it into a class file. Well, this is the first opportunity for something to go wrong. If you don't use proper Java syntax, if you try to nest multi-line commands, if you don't close every curly brace that you open, if you don't close any parentheses that you open, if you misspell the word public, or the keyword public, or any of the keywords that the Java language relies on, you are going to get what's called compiler error. They're called compiler error because guess who catches them? The compiler, javac.exe, okay? The compiler is there to translate your code, but before to translate your code into bytecode, the compiler has to make sure that you wrote code that it can understand, meaning that you use proper spelling of keywords and stuff like that, of names for class and stuff like that. You follow the rules of the Java language, and you use proper grammar. So what does it mean? What is the grammar of a programming language? The grammar of a programming language is what tells you, for example, in a .java file, I should see first a class definition. Inside that class definition, I should see maybe a method definition. Inside the method definition, I should find statement. If I take a statement and I try to put it here at the beginning of the file, here comes the compiler telling me this is not Java. You don't follow the rules of the grammar of the programming language you're using. Just like if I was throwing at you a bunch of English words, but I was not respecting conjugation, I was not respecting grammatical rule, so the words would be just a jumble of misspelled and misplaced words, with no particular order. Good luck trying to understand what I'm telling you. So I told you that programming language are much more formal than actually a natural language, like human language, right? So yeah, they are really formally defined. And if it says that in your file, you start with a class definition and you put inside that class definition, for example, a method definition, and inside that method, the statement, that means a statement cannot be outside a class. That means if I have a method here, like the main method, I cannot take my method and put it outside the class that I'm trying to write. If I try to compile this again, it's not going to compile. I'm not even looking at the compiler errors because I get 7 of them, but the truth is that the first one tells me where the Java compiler loses its stuff, okay? So it tells me on line 5, right here, where the V is, class, interface, or enum expected. So I expected you to define a class, which we know what it is. Okay, this is that, defining a class. An interface, didn't talk about that yet, or an enum. So it told you pretty much you have 3 choices. You should be giving me the definition of a class, an interface, or an enum. I see the definition of a method. I don't know what you're doing. This is not Java, okay? So this is the first category of errors. And so generally, these are the easiest of the 3 that I'm going to discuss. They're the easiest to catch. But you can still, I've seen students struggle for 10 minutes or more, 15 minutes, maybe probably the max, just trying to get their code to compile, okay? So in this class, if your code doesn't compile, you don't get credit. It's like saying you take advanced creative writing, and somebody asks you to write an essay, and they tell you that essay needs to be of the or genre, and you need to do this, and these are the constraints, etc. They ask you to do like a work at a high level, and then you turn in something that is full of typos, that is not even following the English grammar. And honestly, your reader is not able to even tell what your story is about because the sentence do not make sense. If you turn it something like that for an advanced creative writing class, you get 0. In Java, in a programming language, if I turn in something where I typed a lot of code, okay, but my code doesn't even compile, what does that mean? That means that you were not able to run that code. So all of this is pretty much garbage. This is untested code. This is just a brain dump. You just dump on in the JGrasp editor everything that you were thinking could possibly make sense and help you write some code, but the compiler doesn't even recognize that as Java, okay? So you submit a file like this, you don't get any partial credit. We cannot give partial credit to that. So it is really of utter importance for you to always make sure that what you write compiles. So instead of writing like all of this in one shot, then maybe I would be well advised, to write my public class live coding definition, do what I was told, which is, open the curly brace, close it, and then comment it to get that out of the way, and then compile it immediately. You don't get charged $5 every time you compile. It's totally free. So I can hit Control B real quick, and JGrass tells me, yeah, what you typed, I can make sense of it, is Java. Then I'm going to go for public, static, void, main. And let's say that I forget, the parameter here, I forget to close the curly brace. Control B, wow, there's a problem. Reach end of file while parsing. So when it reaches this point in the file, it reached the end of the file, and it was still expecting more. So I look from the line of the error, line 8, upward. What did I forget? Oh, I forgot to close the curly brace. So there we are. Control B. This is a curly brace for the main. So end main method. I don't know why there's a semicolon here. And then I'm going to build that, and so on and so forth. So there are some things that the Java compiler is not going to catch. For example, the fact that I was missing this, okay, is not going to be a compilation error. I'm going to show you more about that like in a few minutes, okay? So the compiler is not that, I mean, it's pretty smart, but it's not that smart. It cannot catch every possible mistake in your code. But at the very least, it can do a good spell check, okay? So things like public, misspelled, static, misspelled, etc. It's going to check that for you, and it's going to check that things are written in the order they ought to be written in a Java program. So following the grammar of the programming language, okay? And once you get all that to pass, okay, so let me use, for example, this example with the string args missing. Once you get your code to compile, you're not done. This is the first step, okay? Code to compile means I wrote my novel and it spell checks, okay. The proofreader, it told me this is correct English. Now I'm going to pass it to somebody else who's going to read my novel and tell me what they think of the story, okay? So now we are ready to run the code. So I'm going to try to run this code, and look, there's another problem. So the problem is no main method, JavaFX application applets or midlets found in file. So we said that we are going to use only main method for now. What do you mean there's no main method? What is this? This is a main method, right? Now, this is a method that's called main, but to be the main, the official main method, I gave you the recipe, right? It has to have this inside the parentheses. That whole thing, what we called last time the header of the method, this is what identified this method. So this method here is the main method, okay? Now we can move on. If I try to compile this, it still compiles. And this time, the main method is recognized for what it is when I try to run it. So it doesn't do anything, but at least it knows how to recognize the main method, okay? So that's the first category of errors. And then we started encountering here runtime errors, which is when you run your code and it crashes. And then we're going to talk about, last part we're going to talk about is logic errors, where your code compiles, it runs without crashing, like we just saw, that pop-up that tells us, hey, I cannot even start your code. And it does something, but it's erroneous. The behavior is not what we expected. And this is going to be probably the hardest category of errors to track down. So regarding syntax error, let's do something real quick here. I'm going to give you a piece of code, and quickly in the chat, you tell me what's wrong with it. So here's a piece of code, and I'm using only the kind of stuff that we played with until now, which is pretty much hello words, right? So it's very similar to what you did in the P, to what you did in the IE. So no semicolon, blah, blah, blah. Awesome, yeah. You guys are fast, cool. So yeah, there is a semicolon missing. You guys are catching on that fast, cool. So here, right here, forgot the semicolon. This is not going to compile, right? So that missing semicolon is a real joke in programming. This is so easy to miss a closing curly brace, a closing parenthesis, a closing semicolon. I've been programming for longer than I care to admit, But the truth is that I still miss once in a while a semicolon, a curly brace, etc. And if I don't compile often, if I compile often, if I type 3 lines of code and I made a stupid mistake like that, the compiler yells at me. I look at the 3 lines I just typed. I'm going to see the missing semicolon. But if you give me like 25, even just like 50 lines of code, 25 lines of code, let's say, and you tell me there's a missing semicolon in there, gee, thanks. that's going to take actually me spending a lot of time, a lot of focus to try to mentally, apply the rule of the grammar of Java, find that semicolon, okay? Sometimes it's trivial, it jumps at you like that. Sometimes it can be nasty to find the semicolon, especially in languages like JavaScript, where the semicolons are not always mandatory. So Java at least is consistent, but some languages are not. So that was the first bug. What about the second bug? What's missing here? No quote. Awesome. You guys are sharp. Okay. So yeah, no quote, but I cheated, I have to admit, okay? Because I cut and pasted the version from JGrass. So it kept the syntax coloring. So this looks like it's green, and it's like a string literal. But really, if I type this in JGrass, it's going to color that parenthesis and that semicolon green. Again, that's why we have syntax coloring, to catch that stuff a little bit more easily. What about this one? Yep, no curly. So missing curly brace here to open the code, okay? And what about this one? Last one, I promise you, we're not going to do that for 2 hours. What about this one? What's wrong with it? Yeah, awesome, no void. Okay, all right, so it's good to be young and to have like a good working brain. I mean, you guys are catching those things really fast. Okay, cool. So congratulations, you developed your first programming skill. Anybody who learned programming, my hypothesis is that they could do very well in a Where's Waldo competition. Okay, yeah, it's attention to detail, and that I cannot make it. I mean, I cannot make it easier for you. Okay, those of you who already spotted the missing element of syntax because you programmed before, or whatever, that's perfect. Okay, those of you who are new to all this stuff and yet were able to spot it, either first thing or after somebody pointing it out, immediately you saw it. Perfect. How many of you were still kind of like having problem spotting those things? I would venture, I mean, even if you don't want to say anything in the chat, I would venture at least, maybe 30, 40%, something like that. That's fine. It's a new type of stuff you're starting to learn to do. Okay, it's paying attention to detail in an almost paranoid way. Okay, you have to be detail oriented. I cannot make that easier for you. This is something that either you have it already or you're going to develop it this semester by programming a lot. But I don't want you to get started with programming saying, oh, I hate being detail oriented and I'm not going to change. I'm just going to try to waddle through programming. This is going to be really painful. Okay, so whether you like or not detail oriented stuff, you know what's in front of you. You know the beast that you are fighting. Okay, you're going to look at code, and sometimes the code doesn't do what you want. Sometimes the compiler keeps yelling at you, even though you are sure that you wrote correct code. Forget what you're sure about. Take a look at the code, dissect it in your mind, figure out, what is a little detail that is breaking everything. And one way to do that is, if I don't know what's wrong with, for example, my method, here, for example, if I type system.out.println, okay, there we go. I type this. It tells me syntax error. All right. So I see cannot find symbol println. I don't know what it's talking about. What the hell is going on? So hold on. I'm going to comment out this thing, my whole method. Does it compile? Yeah, the code without my method compiles. So now I'm re-putting in my code my method, and I'm going to compile the statement here. Comment out the statement. My code compiled without the statement. Now, if I put back the statement, my code doesn't compile anymore. Okay, so definitely the problem is here. So some people are going to just read the error message, which I really encourage you to do. The compiler is trying to help you, and say on line 8, I have an error. More specifically, I cannot find a symbol here. So what is the symbol I'm looking at? Println. Wait a minute. Oh, yeah, that's println. Some people are going to figure it out like that. Sometimes it's not that easy. The compiler error message is not that clear, and you will have to do that little comment out code, try to compile without it, and etc., to find the part that is actually problematic. But if you write only a few lines of code at a time and you compile them very, very frequently, you're going to find yourself not have that many problems with syntaxes. Okay? Second type of error that we talked about. So those are called runtime error. Compile time error is when you translate your Java file into a class file. Then when you try to run the class file, you get sometimes the code doesn't start, like no main method was found, or the code crashes while you are in the middle of running it. Okay, and those are called runtime errors. These are errors that occur while you run your code. So let's take a look at a piece of code here. I have a class. I have a main method. I just follow the recipe so far, nothing new. And instead of doing println, hello world, I use an arithmetic expression here, and I try to compute a division and display the result on the screen. What's wrong with this? Anybody who took already a programming class, you guys know already. What about the others? Why can't I divide by 0? You guys, it's undefined. Yeah. The division by 0 is undefined in math, right? So here, the way Java implement arithmetic, math says so. Yep, that's the way to put it. Yeah, I like it. The way that Java implement arithmetic is compliant with arithmetic, okay, the arithmetic rules. So it says, no, we cannot have a division by 0, okay? All right. So what happened when I try to run this? Let's go live. And we are going to find, first we're going to fix that println. So println 1 divided by 0. Run it, build it, sorry. So it compiles. That's the problem. It compiles. The compiler cannot actually understand that this is a problem. It just says you are trying to define a class. Inside the class, you define a method. Inside the method, you have a println statement. That println statement is taking as parameter what you want to display is an expression. The expression is well-formed, meaning that it's an arithmetic expression that makes sense, okay? That's it. Spell checking, right? But what the expression is going to be evaluated into as a value when you run the code, the compiler doesn't know that. Compile time happens, we generate the class file, then we run the class file, and we see what's actually happening when you run your code. So compile time, runtime. This is a runtime problem. I try to compile that again, no problem. I try to run it. There we go. So get used to this. When you run code, sometimes you're going to get that word exception. Exception means something went not the way that I expected, okay? So exception in thread, main, blah, 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 a lot of jargon, okay? But it tells you, it tries to help you understand what kind of exception happened. Java.lang.arithmetic exception. And then it tells you this is a division by 0. And it tells you where it happened, line 8, okay? So this helps you figure out what happened at runtime. Okay, so syntax error, runtime errors. What about the last category? Let me move that guy again. What about logical errors? So logical errors are also a type of runtime error. The difference is that your program runs, your program compiles, okay, fine. It executes, you can run it, and it doesn't crash. So no exception in the console, okay? Like here, the program completely stopped executing in the middle of line 8 and told me, you know what, I cannot continue like this. There is a problem. So no crash, but now the program is just incorrect, which is like the most of the time, this is what you're going to deal with. So let's take an example. Somebody comes to me and say, here, I'm going to teach you how to convert a temperature that is expressed in Celsius degrees to Fahrenheit degrees. So I give you a formula. The formula is the value in Fahrenheit degrees is 1.8 times the value in Celsius degrees plus 32. this is not Java code, by the way. This is not Java syntax. You see that we don't put a multiply symbol here between 1.8 and C. This is just how you would write it in a math or physics class, right? And then we run an example together. If C is 37, then 1.8 times 37 is 66.6 plus 32, 98.6. So I explained to you how to compute what is a formula to use to compute a conversion from Fahrenheit to Celsius. And then I gave you an example that you can use as a test. Okay, when you write your code, if I give you a temperature of 37 Celsius degrees, you should spit out an answer which is 98.6 degrees Fahrenheit. Okay, so now I'm writing this code. I'm writing this code, class definition, inside the class definition, main method definition, kind of like my println hello world, Celsius 37 is equivalent to this many Fahrenheit degrees. So a little message to let the user know what happens. And then a formula here, an arithmetic formula. I try to display the result of evaluating that arithmetic formula. So 1.8 is 9 divided by 5 times 37 plus 32. I used exactly the formula that was here. I used the example that was given to me. I just want to make check. I just want to make sure that I can compute the conversion of 37 degrees Celsius into whatever its equivalent in Fahrenheit is, which is 98.6. So I compile this code. Good news, it compiles. I run this code. It doesn't crash, but it displays on the screen. So everything would be on the same line. I just reformatted it for the slide, okay? Celsius 37, so there we go, Celsius 37 is Fahrenheit degree 69. What's happening here? That should be 98.6. What happened if we put 1.8 instead of 9 divided by 5? So good suggestion, second suggestion, order of operation. So yeah, something a little more fishy is going on here. So let me grab, I should have cut and paste that. Where is my, where's my slide? My slide. Okay, I'm going to just paste the formula because I'm lazy. There we go, copy. And then I'm going to go back into JGrasp. Make sure that I can still see the chat window. Where's my JGrasp? Here we are. So let's go ahead and let's try to paste that formula here. So just a quick advice, when you paste from a PDF or a slide, okay, edit, paste special, and then rich text format. That's going to spare you a lot of trouble, okay? So I pasted the formula here. So if I run this, compile it first, yes, it compiles. Actually, no, it doesn't compile. What did I do? Oh, I have an extra parenthesis here that I should not have. There we go, see? Extra parentheses, missing parentheses, always a pain. Build it, run it, 69. So it doesn't work, right? So the suggestions, what happens if we put 1.8 here instead of 9 divided by 5? Let me try. Let me start this by this one, okay? 1.8. There we go. Build it. It works, okay? So 37 and 32 are integers. 1.8 is called a floating point number, a number that has a decimal part, okay? An integer part and a decimal part. Okay, and I run it. Hey, that worked. I mean, there's a little bit of weird stuff going on here with all those zeros and one. I'm going to talk more about that, like probably within a month, okay? But right now, okay, right now we still get 98.6, sort of, and we avoided that big problem. So the second suggestion was order of operation. That's actually a good suggestion as well. That's why I used those parentheses. I wanted to make sure that first we did 9 divided by 5. Then I could be even more paranoid and say, then I want to do the result of 9 divided by 5 multiplied by 37. Then I want to use 32. But yes, I have more to tell you about the order of operation indeed. And we are going to cover more about that, okay? But for now, yep, I can add parentheses like that, you know, and make it sure, 100% certain that Java understands exactly the formula I want to use. But if I run this, I still get 69, okay? So, and I saw in the chat window another solution that I like very much. So what's happening here? We are going to talk more about that in 1 or 2 sessions, promise, okay? But what's going on here is that 9 divided by 5 is our problem. When I replace it by 1.8, it works. If I put, like somebody suggested in the chat, 9.0, which sounds like it's the same thing than 9, and 5.0, which sounds like it's the same thing than 5, right? And I try to compile it, it works. And then when I run it, it gives me the right result. So what's going on here? What's going on is that there's much more for us to learn together about computer arithmetics, okay? Yes, 99.9% of the time, the way that you write a simple formula in K12 is going to be the way you write a simple formula in Java, okay? But there are some differences. For example, Java has a concept, and any programming language has a concept of data type. This is a piece of data, right? Like 37 here. This is a piece of data. But in math, in a math problem, I would say 37. Yeah, 37 is a value 37. I don't care. What else do you want me to tell you about 37? Well, in Java, I would say that 37 is an integer data type value. So integers, you know what they are, right? -1, 0, +1, +2, etc. So all of those positive and negative integers, they form a data type, a family of values. And this here, if I write, for example, 37.0, it's still the value 37. But now the value 37 has a data type floating point number. And the way that you do addition of two integers or division of two integers, and the way you do division of two floating point numbers is different. When you do a division of two integer value, and I'm not ignoring the chat, okay? I'm just finishing this explanation and then I'm going to catch up, okay? If I do a division of 9 as an integer value by 5 as an integer value, here's the result. That's what we call the integer division. The result doesn't have any decimal place. But if I say I want to divide a floating point number, okay, with another floating point number, even though they have the same value, right? Then Java says, oh, you want a floating point division. So you want me to keep track of all the places after the decimal dot, okay? So yeah, that's the kind of stuff we are going to dig into during this course, right? So it's simple until, well, yeah, there's just a little detail there. And that's my job, right? My job is to draw your attention, make sure that you remember this. That's why we spent 5 minutes on it. I could have said that in 10 seconds, but I wanted to run it, show you the code, talk to you in the chat, interact so that it's more likely to stay in your minds. Okay, now you have a warning in your brain that says, well, you know what, computer arithmetic, yeah, I need to learn more about that. And that's the beginning of it, right? So can I do 9 divided by 5.0? Yeah, there are rules. Okay, so 9 divided by 5.0 is still going to give me 1.8. Okay, so again, we are going to cover all those rules. Okay, let me catch up with the chat. So somebody suggested that 9.0 divided by 5.0, kudos, awesome. Modifier, nope. Level 42 wizardry, maybe. But you guys need to be level 42 by the end of the class, and you will be, okay? So it's just not some wizardry. It's just weird. It's a weird wizardry, okay? So that means that if you don't know anything about programming, you don't know anything about computer, then this is going to catch you completely off guard, right? But that's not you. You guys are going to go into information technology, cyber security. So that's it. You are going to know about all those little quirks, etc. Okay? Typecasting can be a pain. Yes, yes, it can. We'll spend time, like around the middle of the semester, a lot of time on typecasting. What if you had two numbers with one decimal place that end up with a result with two decimal spots? So good question. Java doesn't care if there is one decimal here or two, like for example, 5.00. It cares about, do you have any decimal at all? If the answer is no, you are an integer. If the answer is you have at least one decimal, even if the decimal number is 0, then you are a floating point number. You see the concept of data type? There are two things here, the value, which is 5, and the data type, which is what kind of number is this? This is a floating point number. This is an integer. Both of them have the same data type. Well, when you apply operation on them, it matters what data type they are, because the way that inside your CPU, your processor is going to divide two integer value is actually different from the way it's going to divide two floating point value. There are two different instructions there at the base level, the machine language level. There are two different instructions, more actually, and they are going to operate differently. They are going to use the bits in memory differently to compute the results. So that low-level stuff that we talked about, bytecode assembly, now we don't need to know a lot about that low-level stuff, but we need to be aware to a certain extent of that low-level stuff so that those rules, they kind of make an intuitive sense. Okay, my CPU treats differently integers and floating point number. Guess what? Java is going to have me distinguish between integer and floating point number for that reason. Now, there are other languages like JavaScript. They just consider numbers. They don't care about floating point or integer. They manage it themselves, internally. But again, different languages are different. The vast majority of language is going to ask you to know the difference between an integer and a floating point number. Okay? That should work since they are both floating point number. Exactly. Perfect. Okay. So, all right. So this is what I had to tell you about that simple division here. Now, what we are going to do, we have a little bit of time left. So I'm going to close this slide. We are done, officially done with module 0. We're not going to have time to get started very far in module 1, but I want to just get over, the logistic stuff so that next session we can hit the ground rolling and we can make progress. Okay, so I have a little bit of just introductory stuff. We are going to go over it like right now. Okay, so let me resize this so that I can still see the chat. Okay, so this is a slideshow for our next module. So I'm going to upload the video recording under the module 00, okay, just because there's going to be only 10-15 minutes here of module 1 in it. So I'm going to upload the video for this whole session under module 0. I'm going to upload the slides for that session, the PDF of the slide under module 0. And then in Canvas, you're going to have a new module 1 that's going to appear. And I'm going to upload the slides for that module in that new module. And there's going to be a bunch of links for the different learning activities that we are going to go through. Okay? So module 0 was your introduction to computers and programming, etc. I know for a lot of you, for some of you at least, maybe 30%, something like that, that was all news. That's okay, that's all right. We are just trying to make sure everybody gets started from the same base, okay? I don't want to burn through this too fast and then lose already, like 50% of my students because they registered to an introductory course and the introduction was not there, right? So yeah, we have our introduction to basic stuff like that just to get you pretty much in the mood, right, in the flow of things. So we talked about what programming language are, what programs are, how to get them to run, to compile. Okay, well, now we're going to talk about what programming is. So the activity of writing code. What are the rules? What are the options? What are the alternative possibilities, etc., whatever you want to call it, okay? So how do I come up with the code that I write in my Java file so that I can achieve a specific goal? That's going to be the focus of this module. So module 1, 01, M01, we're going to start with what I call the building blocks of programming, okay? And I'm going to explain just a little bit about this, what we're going to do here, just so that you know the general idea about, what kind of pedagogy I'm going for here, why we are doing things like this. So the module, starting with module M01, then module M02, module M03. These 3 modules together are going to take about, I would say, 5 weeks if we go at the same pace, than previous semester. And they are going to constitute actually a sort of self-contained introduction to programming. You are going to be able to program at the end of module 3. We will learn together how to program in Java by module 3. So what does that mean? That we can go ahead and take a vacation after that? Not exactly, okay? What we are going to do during those 3 modules is my objective will be to take every student in this class that has never written code and make sure that they have some sort of process. They have some sort of guidelines in their mind when they have to write code. And they think in terms of, well, I have to write code that does this, and so here are my requirements. I'm going to start by doing this, then this, and this, and that. I have a process. So we are going to focus on the programming thought process. What is the thought process I want you to go through as you're writing code to fulfill some requirement? So to be able to do that in 3 modules, something has to give. We have to make something a little bit simpler. So I really want you to understand how to program, because this is really the difficult part in this class if you've never programmed before. And I want you to have a basic idea of how to write simple code by the end of module 3, so that we have the rest of the semester to practice that skill, which is the #1 skill we want you to develop in this class. So I don't want to finish week 15, and week 15 reveals the skill that this whole class was about, and nobody gets time to practice it and internalize it and develop it, okay? So we are going to have like this little cycle, module 1 to 3, where you are going to learn how to program. And what we are going to be light on is Java. We are going to use, I would say, a simplified version of Java. I've called it, you are going to hear me say in the lecture, just enough Java sometimes, or Java for now edition, okay? So it's not an official edition of Java. That just means that Java is a topic that we can study together for 1 semester when you already know how to program in Python. You could take a course that's going to just teach you how to program in Java, assuming you already know how to program in another language, okay? And that would take us a whole semester. What we have to do this semester is we have to do a little bit of that, but we have to mostly make sure that if you never wrote code before, by the end of the semester, you are able to write code. These are 2 different things. Being able to write code, design programs in your head is one thing. Being able to get them to work is part of it, right? But knowing every little thing there is to know about the Java programming language, that's like a bonus, cherry on the cake kind of goal there. So that's not our primary goal. So for those 3 modules, we are going to definitely learn how to do things in Java the simple way. If there are 5 different syntaxes to do something, 5 different available ways to write code in Java to do one thing, I'm going to pick one, the one that's the most bulletproof, and that's the one that I'm going to teach you during module 1, 2, and 3. And that's it. So we take it easy on the syntax, take it easy on Java, just use a subset of Java, just enough Java to be able to learn how to program. And then module 4 up to 9, we are going to revisit the same concept that we went through during module 1 to 3, like the big concept in terms of, what can you do with a program. But this time, we are going to drill down into the details on how Java works, on how Java allows you to do it. So it's going to be a 2-step process, right? First layer, module 1 to 3, focus on learning how to write code from scratch. I gave you requirements. I want you to implement a piece of code that fulfills those requirements. And then go light on the Java. Module 4 to 9, revisit again, re-practice the skills that you just discovered about writing code from scratch. And at the same time, because if we just redo twice the same thing, it's going to be really boring, right? At the same time, I'm going to add more knowledge about how the Java language works, operate, what the syntax is, what the option, etc. Okay? And how it operates a little bit under the hood. So we're going, this is the goal of this course, okay? This is the structure of this course. So for this module 1, we're going to have, again, the typical learning activities that you find in the module. So all done, because we're just starting module 1 right now. We're almost done with the session, so I'm not going to do anything really like meaningful in terms of the content of module 1. We're just getting rid of the introduction here. So all done. Don't click on PQ1 because it's not going to make any sense. Even less, don't click on GQ1 because GQ1 is a graded version, right? So I'm just telling you, these are going to be part of your module. And I'm going to draw attention during the slides as we go through module 1. I'm going to tell you, now is a good time to start practicing with the PQ, okay? Now you're ready to go ahead and take the whole GQ if you want. So work with me, okay? Let me introduce you to those learning activities as they become relevant, but I want you to have upfront an idea of what's coming to you. So we are going to have a PQ, same principle than before, a GQ, same principle than before, and if that doesn't make sense, please post on Piazza, okay? I don't want to keep repeating the same thing, but of course, if you're not yet comfortable with the difference between a PQ and GQ, you need somebody to clarify that for you. I'm here. All right, then we're going to have a practice exercise. We're going to have several practice exercises this time, okay? And again, I'm going to tell you in the slide when we reach the point where I've shown you enough that you can go ahead and practice meaningfully with those exercises, then I will mention it in the slides, okay? So the slides are going to guide you through those activities. And then IE1. So IE1, there is a question mark here. I haven't made up my mind yet. We just add an IE. So on the one hand, I don't want to make this, that's a dreaded forced march through the desert. I don't want the pace to be incredibly unsustainable. At the same time, I0 was meant to be really super easy. And I hope that for most of you, and I'm talking about the people who learn to program for the first time, okay, this semester, even if this was the first time you run a Hello World, I hope IE0 was indeed, easy for you. If not, it's already time to come and work with us during office hours, okay? We need to help you out. IE1, last semester I skipped. I didn't do an IE1. We had like a few weeks where we didn't have IEs. I'm considering trying to insert an IE1 here. Try to make it, again, a little bit more complicated, but not too much, just to keep the pace going, okay? So I'm still debating right now. It depends on how I can shape the IE1, how fast we go through the material, okay? But the idea would be that this week we have only lectures, and then the next week, at the end of next week, we will have a small IE1 due, like maybe a half an hour, maybe 1 hour, something like that, okay? Not the full 2 hours yet, but we are ramping up progressively. I'm a big believer in, starting early, regularly, and ramping up progressively, okay? If you follow along, you'll be fine and you'll reach a final comfortable. So what we're going to talk in that module 1, I'm just going to give you the taste of it, okay, and then we'll stop. So what we're going to talk about in module 1 are building blocks of programming. I didn't used to teach programming like this at all. I started talking about building block and being more and more detailed about them when I realized that for some students, there was this overwhelming effect of programming on their mind, meaning that they were staring at a blank page, like a writer block, like when you're trying to write a novel, a story, or whatever, and you are staring at that blank page on your typewriter or word processor, and you just don't know even where to start, okay? So I've seen that over the years a lot, okay? There has been always a good significant portion of students who just learn to program that have this writer block pretty much when they have to start writing code. So that led me to be more specific about, the programming thought process, which is going to be module 1, 2, and 3. I'm going to give you an idea of how you need to write code. But I need also to give you something to start off with, like an alphabet, okay? If I'm teaching you German, one of the, I would never teach German to anybody, that would be a bad, but one of the first things we're going to do is at some point talk about the letters of the alphabet, right? It's even more true if you're learning Japanese, Russian, or Chinese, right? Or Arabic. Those languages have different letters in the alphabet. So that's kind of like the very basic stuff you need to know about a language. Otherwise, you cannot read and write. Well, it's the same in programming. But the thing that's funny in programming is that the way that you are going to learn programming is not totally unlike you would learn something like chess, okay? I'm assuming almost everybody knows how to play chess, okay? Let me know if you do in the chat. Doesn't mean that you're good. For example, I'm horrible at chess, but I know how the pieces are supposed to move, right? So that means that technically I can play chess, but I'm going to make a fool of myself, right? So that's the thing about chess. When you learn chess, a lot of people are just going to be able to play chess. And if I ask you, how long would it take you to teach me chess? What would you say? Those of you who know how to play chess, even the ones that just barely know how to play. If you wanted to teach me what you know, how long would it take? Take a guess. 5, 10 minutes? Yeah, that sounds reasonable to me. Okay. So what are you teaching me for? You are teaching me the pieces and how they move. Now, how long would it take you to teach me to become a chess master, even assuming that I could possibly become a chess master? Yeah, years, exactly. A lifetime? Yeah, I kind of agree to that too. So you see the difference? Okay? Same thing with programming. How long, how long does it take to learn the building blocks of programming, what they do, what they mean? Not too long. Module 1, we're going to get this over with, okay? How long is it going to take you to become, comfortable with programming? It's going to take a lot of practice. But here's the catch. If you don't know your building blocks, then no, you're not going to be able to learn anything. You're going to be able to listen to lecture and retain a little bit of them, but you're not going to be able to make progress in programming, okay? Think of it in this way. If I learn chess and I know, for example, how half the pieces are moving, and then I start learning my first games, and when I play an opponent, there are pieces that I'm not even using because I don't know how they move. Sometimes the opponent moved their piece, but I could not anticipate their move because I didn't know that piece could move that way. Okay, stop. Instead of spending more time playing chess competition or trying to learn strategy, I need to go back to learn how each of the pieces move. Okay. If you're not agreeing with this, talk to me. I need to convince you. This is super important, right? The analogy with chess is not correct 100%, but it's enough to give you the idea that in programming, you are going to learn about those building blocks, what kind of basic operation we can perform with a program. And then you're going to learn to recombine those building blocks. And then when you recombine the building blocks, you can do things that are more complicated. How complicated? Infinitely complicated. Okay? So that's why some students, when they look at a requirement and they look at their program, their JGrasp, and they say, I don't even know where to start. It's because you are looking at the whole game. But really, in chess, you have to move one piece at a time, and each piece has only a certain way to move. So if you are really lost, you know what you do? You look at each of your pieces one after the other, and you ask yourself, well, would it be a good idea for me to move that piece? And then knowing that in the current state, I can move it 3 different ways, what is the best way for me to move it? And then you're going to start thinking strategy, okay? But it's absolutely, this is the most important thing for the end of this lecture, and we're going to finish now. I want you to remember, if you don't know how all of your pieces are moving, if you are not 100%, and that's the expectation, you have to be almost perfect on your building blocks, on your syntax. If not, then you don't have the proper basic literacy to pile up more knowledge about programming. So this is going to be, I promise you 2 things. This is going to be an easy module. You could actually learn it just by memorizing, okay, brute forcing it. So there's nothing in this module that somebody in this class is not capable to understand. You all graduated high school, right? So you're okay with the complexity. But if you suck, if you do not actually, do you apply yourself to this, do your best, okay, then you're going to start paying the price immediately, starting with module 1. And then module 2 is going to get worse, module 3, module 4, and so on and so forth, okay? Thank you so much for the patience. I know I'm 3 minutes over time. Sorry about that. Feel free to leave, and catch up on the video recording when I do that. But thank you again for your attention, and I'm going to stop the recording. I'm not going anywhere. If you guys have questions, please feel free to hang around, and I'll be glad to help you out. All right.